All right, hello everybody. This lesson is going to go over some stuff about angles. It'll be our 6th and 7th lesson in this concept. So here we go. Let's get started. All right, so our first conversation here about angles starts with a ray. So a ray is part of a line starting from an endpoint. Remember, we had a line goes infinitely in both directions through 2 points. A segment stops at 2 endpoints. A ray is one portion of a line starting at an endpoint going in one direction forever. A ray is one of the components to an angle. So opposite rays, down here in the second picture, like BA and BC would be opposite rays. Opposite rays form a straight angle or 180 degrees. Alrighty, so here we go. Let's talk about angles. Angles, very important to geometry. An angle is a pair of rays that have a common endpoint. So here in our top angle, we would see that A is the endpoint. Okay? So we could name that in a lot of different ways. We could name that angle A, angle DAB, angle DAC, any sort of way, any number of ways. The sides of an angle are the rays. So 2 rays form an angle at a common endpoint. The rays are the sides. So what you can see down here in the bottom is we have side AD and side AB. All right, moving on. So we have portions of angles. So A, D, B, and C in this top all lie on the angle. In the bottom here, G, F, and H are interior to the angle. So these are interior on the inside of angles. And then I, J, and K are exterior to the angle because they are outside of the angle being formed. All right, so quick question here. Use the figure to identify angles or parts of angles that satisfy the given condition. Which angle has sides D, B, and DC? So I'm going to take my pen here. I'm going to switch it to red, and then I'm going to highlight those rays. So DB is this ray, so there's DB, and DC. So now we're going to talk about how we can name these angles. So angle 2, that works. Angle ADB, that is not true. Angle CDB, that works. Angle 3, not true. Angle BDC, that works. And then angle EDC would be angle 4 down here. So that one does not work. Alrighty, resuming here, let's go on to the next one. Congruent angles. So the measure of an angle is the measure of the degrees in the space between the sides of an angle. There are 360 degrees in an entire circle. We'll talk about why that number ended up. Why not 350? Why not 400? We'll talk about that later. Why 360 is the number. But 2 angles with the same measure are congruent. We'll also talk about measuring angles. We'll talk about a lot more of this. So here we go. We have down here QTR is 60 degrees. RTS is 60 degrees. So therefore, QTR is congruent to STR because they have the same measure. Now, I want to point this out. Much like segments, angles are congruent. So if we notice, we've got the congruent symbol right there. Their measures are equal. So it's a slight difference. But remember, geometric figures can be congruent. Their measures are equal. So it's just a slight little difference there. All right, another quick problem here, a little check. This is going to have some algebra here. So KM and KJ are opposite rays, meaning they're equal to 180 degrees. We have JKN is equal to 8x minus 13. NKL is 6x plus 11. And it also says that KN bisects JKL, meaning that this angle is congruent to this angle. And actually, we're looking for the angle JKN. So what we can do here is we can say that 6x plus 11 is equal to 8x minus 13. We can solve our equation. I'm going to subtract my 6x over to get 2x. I'm going to add my 13 to the other side to get 24. That would make x, as we divide by 2, equal to 12. And then we need to plug it in to one of our angles since they're equal. I'm going to plug it into the top. 6 times 12 plus 11. 6 times 12 is 72. And 11 is 83. So therefore, each of these angles are the measure 83. So we'll go ahead and we'll write that over here in our little answer line. All right, next slide. Special angle pairs. So adjacent angles are angles that share a ray or a common side. So on the left here, 1 and 2 adjacent because they share this ray. Here, the 1 and 2 they're next to each other. They're not adjacent because they do not share a common ray. All right, linear pair. This is a lot of vocab words that you've learned over your geometry career, 6th, 7th, 8th grade. So we're going to go over it quickly. We will use this all year. So don't worry about if you don't kind of have it memorized right now. So a linear pair is an adjacent angles that share a common side whose sum of the angles are 180 degrees. So we're also going to see a word here in a little bit called supplementary. Here, angles 1 and 2 are supplementary, but they're also a linear pair, meaning they form a line together. All right, vertical angles are two non-adjacent angles formed by intersecting lines. Vertical angles are congruent. So here in this drawing, angle 1, angle 3 are congruent. And then if we also, angle 2 is congruent and vertical to angle 4. All right, sliding down. All right, so this is your first set of daily practice. The page is printed for you. The numbers are in the Schoology update. You can also pause and write them down here. But you can either stop and do these now or finish the video and do them afterwards. All right, so lesson 7 is special angle relationships. This is where we're going to get into complementary versus supplementary. So any two angles that are complementary add to be 90 degrees. They do not have to be adjacent. Okay, that is something extra. Any two angles who add to be 180 degrees are supplementary. They can be anywhere in space. Now, if they're adjacent, they become a linear pair, and that's what I referenced earlier. So E and H here are supplementary, but not linear pairs. K and B here are complementary. Looking here, these are now complementary angles that have a common side. On the right here, these supplementary angles, UVW and WVX, are a linear pair because they both are adjacent and supplementary. Alrighty, another important term in mathematics or geometry is perpendicular. So two lines are perpendicular if they form a right angle. So if I were to draw two lines or segments or anything, okay, or rays can also be perpendicular, and they form 90-degree angles. So let's call these two segments, we'll call this AC, and we'll call it DB. These segments are perpendicular if and only if they form a right angle. This is the symbol we would use. AC is perpendicular to DB. We'll talk a lot about perpendicular segments and lines in a couple of days. So here's just a couple of pictures. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form 4 congruent angles. All right, so this is kind of an interesting thing. It's important to know that we cannot assume everything about a picture unless we're told it in geometry. You can't look at this diagram right here and assume anything unless it's marked down, okay? The only thing you can really assume is that things intersect at H, like HJ and HG intersect. HK and HL intersect. That you can assume adjacent angles, linear pairs. You can assume supplementary because we know that HG and HJ form a line. So therefore, you can assume that JHK and KHG are supplementary. You can't assume perpendicularity, and you can't assume congruency. You cannot assume from this diagram that GHM and JHK are congruent, even though they look it. So here we go. We're going to go through it. Now we've got some information here. Okay? Do you notice here we've got some markings? We've got this tick mark, meaning HJ is congruent to HG. We now know that these two little angles are congruent, and we know that this is a right angle. So now we can go through and look at each of these and decide which ones are true and which ones are not true. So KHJ and GHM are complementary. Complementary means they form a right angle. Those do not. Those are congruent, not complementary. All right, looks like my pen's not working for me right now. All right, so A is not true. GHK and JHK are a linear pair. Yes, B is true. So B would be correct. HL perpendicular to HJ, that is not true. We do not know that. So that's an X on C. D, GHM and MHK are adjacent. Yes, they share the ray HM. And then finally, HL is perpendicular to HM. Yes, that one is true. So in summary, we have this one true. We have this one true. This one is not true. B is true. And then A is false. All right. This is your daily practice for this lesson. Again, try to finish what you can. We will go over this in class the next time I see you.